video we will understand the concept of phase sequence and how, as we change the phase sequence of a three-phase induction motor, how the rotor rotates in a different direction. So let us first understand the diagram and then we'll understand the statement. So here, as we are aware that if these are the flux lines, I repeat, if these are the flux lines, and if the force experienced by the conductor, let me take another color for the force. So let us say this, if this is the force experienced by the conductor, if this dot is the conductor, and if this is the force experienced by the conductor, what is the magnetic field induced? And again, if this is the conductor and if this is the force experienced, what is the magnetic field induced? So if the force is parallel, we'll have zero induced EMF. If the force is perpendicular, we'll have maximum induced EMF. So I hope this you've understood under single phase circuits. So if this is the conductor here, and where is the force? This is the force, right? It is not exactly perpendicular, but it makes at some angle. So I want you to understand that whenever the rotor, so if let us say this is the rotor or this is one phase, okay, I know that the conductor, as you can see, this is where the students, they go wrong. So the conductor is actually parallel to the flux. I repeat, the conductor is actually parallel to the flux, but the force is actually perpendicular to the flux. Thus we'll have maximum induced EMF. So as you can see here, at this point, the induced EMF is not maximum, it is slightly lesser because it is maximum at this point. So somewhere here we get maximum flux. Sorry, maximum induced EMF, not maximum flux, but maximum induced EMF. So similarly, when this, so you can see here, when we only at this point we get maximum here. Okay, at this point it is slightly lesser. So as the conductor, this phase B conductor comes to this point, and the force is actually, as you can see, the direction is rotating in clockwise direction. Thus, it is the force acting at this point of time, it will be perpendicular to the flux. Thus we get maximum induced EMF. Where? For the blue color. So you can see here. So as of now, right, as of now it is somewhere here. So when this phase comes at this time, we get maximum induced EMF. Now let's see the statement of phase sequence. The order in which three-phase voltages attain their positive peak value is known as phase sequence. So you can see here which attains positive peak first, right? So you can see from this instant Y has already left, and we assume that positive, we get maximum only when the force is perpendicular. So if this is if these are your flux lines, right, and on the north pole only we get positive values, and at south pole we assume we get negative values. So when the conductor comes parallel to the flux lines, or the force experienced by the conductor is perpendicular, only then we get maximum. So from this instant, Y has already left. I repeat, from this instant, Y has already left, B has already passed north pole. So from this instant, which is hitting the north pole first, or which conductor comes parallel to the north pole, or which conductor's force is perpendicular to the north pole, right? So phase R, right, would come from this instant. I repeat, from this instant, phase R comes under north pole first. Thus we have R first. So after R leaves north pole, which phase comes under north pole, right? As you can see, based on this direction, as R leaves the north pole, we get phase B. Thus we have phase B. So after phase B, we have phase Y, which is coming under north pole first. So why I am considering a north pole? Because they have told it is positive peak and not negative peak. Okay, so this is how we understand phase sequence. So let's take another example to understand. Now here I want you to write down what is the phase sequence for this rotation and for these phases. So according to the statement, it is which attains their positive peak. So concentrate on north pole. So which vector will leave the north pole first, or which conductor will force experienced by the conductor is perpendicular to north pole first. So B has already left. So which will come first? So phase R would come first. and then after R, which phase would come? We'll have phase Y, right? We'll have phase Y. So after Y, we'll have phase B coming under North Pole. So that's the phase sequences R, Y and B. So let's take another example here. So in this example, you can see the rotation is now changed. The phase sequence are also changed. So I wanted to pause the video and analyze what is the phase sequence. So I hope you have analyzed. So let's verify now. So now according to this direction, it rotates in anti-clockwise direction. So which vector or which phase hits the North Pole first? Or which conductor experiences its force perpendicular to North Pole first? So which pole, which phase? We have phase Y, right? Followed by we have B and then we have R. Thus the phase sequence is defined as the order in which the three phase voltages attain their positive peak values. So thank you for watching the video. So please do subscribe the channel to enhance your knowledge further.